Hello. In this video series, we will learn about Kmeans clustering algorithm. It is algorithm popularly used for unsupervised problems. Basically, we need to understand concepts of clustering. Clustering is the grouping the data points of data sets on basis of their similarity. It is unsupervised algorithm. So, it is implemented on unlabeled data set normally. There are various types of clustering. Now these clustering algorithms are like partitioning, hierarchical or density based clustering. K-means is a type of partitioning clustering. It divides the data into k non-overlapping subsets or clusters without any cluster internal structure or labels. It is an unsupervised algorithm. Cluster formation is on similarity of objects based on their features and differentiates from other objects. So next question is, what is the difference between classification and clustering? Actually, classification is used in supervised learning techniques where feature sets are labeled, whereas clustering is used in unsupervised learning where similar instances are grouped based on their features. For example, we have feature set containing customer age, name, loan taken, education, etc. And we wish to group the clients based on their income and age, and here we can implement clustering. We cluster them based on the similarities of features. Objective of the K-means is to cluster objects based on their similarity features by generating similarity matrix where the distance among the objects using their features are achieved, and cluster them by minimizing the intra-cluster distance and maximizing the inter-cluster distance. We will learn about this in detail and also implement K-means using Python in our next lecture. There are many approaches and functions available to measure the distance between two data points. Some of these dissimilarity distance methods are Minkowski distance, Euclidean distance, cosine similarity, average similarity, etc. Let us take an example and understand the process of clustering. Assume we have data set having clients and each client is having one feature, that is age. So, for example, as shown in the example number 1, as it is shown here, the distance measured between customer 1 and customer 2 can be calculated using dissimilarity measurements, any one of like Minkowski distance, Euclidean distance, cosine similarity, average similarity, etc. Here we are using Minkowski distance. Actually, selection of the distance measurement depends on the type of problem. We will understand about these in some future lecture. Now, look at the first example. Here we have calculated distance among x1 and x2 using only one feature, that is age. Suppose we have two features with us, namely age and salary. Then, as shown in example number 2, we obtain the dissimilarity distance, which is square root of sum of features, as we have two features, namely age and salary in this particular case. This is how we find distance among two data points of data sets. Let us understand this concept in detail. Assume we have multiple clients to whom we represent using scatter plot. All these objects are having two features, namely age and income. Hence, we are representing them in two-dimensional space. Our objective is to cluster these clients' data set in clusters based on their features. So, our first step is to determine how many groups or clusters we are aiming to create. And also first step includes to determine value for k, which is number of clusters. Let us talk about the first step, random selection of centroid. how to determine number of clusters, and that means value for k is important objective. Consider we have selected value for k as 3. That means we require 3 points which represent these in the data set, and we call them as centroids. Now question is how to select the centroids. Well, there are 2 ways to determine these centroids. First is selecting any 3 data points from the data set as centroids, and second approach is creating any 3 random points as centroids. Here we have created 3 random centroids. Now second step is distance measurement. Now second step is grouping each data point which represent clients by calculating the distance from the centroids. This distance calculation is using appropriate distance dissimilarity measurements. As we already discussed, we have many such measurements methods like Minkowski distance, Euclidean distance, cosine similarity, average similarity, etc. Selection of distance dissimilarity measurements depends upon the type of problem. Here we will use Minkowski distance. For each data point, we will obtain 3 distance measurements for 3 centroids in our case. As our k value is 3, hence we obtain distance matrix which represent distance of each data point from the centroids. Third step is to assign each data point to nearest centroid. Based on the closest distance from the data point to the centroid, the data point falls or grouped in that particular cluster represented by the centroid. This is how initial clustering is formed. Each data point falls in particular cluster represented by its centroid based on the shortest distance to the centroid. However, this cluster's formation doesn't seem right because the centroids were chosen randomly. We call it as error forming the cluster. This error is actually distance from the data point to the centroid. Hence, the error in the cluster can be represented as sum of distances from each data points of the clusters to the centroid. We calculate this error using mean square error or MSE, which is sum square of distance from each data point to the centroid. Our main objective is shifting the centroid so that this error is minimized. Now, the fourth step is to compute new centroid. In process to minimize the error, we calculate mean for these data points of the cluster and shift the centroid to the new centroid. For example, we have 2 data points A with features at 7.4 and 3.6 and another point B having features 7.8 and 3.8. Then the mean is 7.6 and 3.7. Hence the centroid will be at 7.6 and 3.7. Similarly, in cluster we have many data points. We find mean of all these data points features and obtain new centroid for each cluster. And now the fifth step. Again, we will obtain distance matrix for each data point and the space related to all 3 centroids, and again based on the shortest distance from the data point to the centroid. In other words, based on nearest centroid, the cluster will be formed. Hence, we have reclustered with new centroids. These 2 steps of forming cluster based on shortest distance from the data points to the centroid using distance matrix followed by finding mean among the data points available in the cluster and moving the centroid are repeated. This is iterative process, and at end of every iterative process we obtain new centroid and cluster information. This process continues until the convergence is obtained. In each iteration, it will move the centroids, calculate the distance from the new centroids, and assign the data points to the nearest centroid. As a result, we obtain the clusters with minimum error or the dense cluster. Actually, this algorithm is heuristic by nature. It does not guarantee to converge to the global optimum. This algorithm is guaranteed to converge, but it may be local optimum and not the global optimum. Actually, the result depends on the initial cluster selection. This is iterative algorithm, and hence for initial value of k, it runs for multiple times to form the cluster until it reaches to the convergence. The algorithm is very fast, so performance is not an issue as far as the number of iterations are concerned. For better obtaining global minima, it is highly recommended to reiterate the process by random selection of new centroid and repeat the process. K-means clustering is unsupervised algorithm, and as we saw, the algorithm performs iteratively for k value. Let us summarize the steps. First, initialize value for k and randomly place centroids. Second step is calculating distance from each data point with each centroid and generate distance matrix. Third step is assign each data point to the centroid which is closest one and hence form the cluster. And fourth step is find mean value and recalculate the position of the k centroids. Finally, check whether the convergence is achieved. If it is not, then repeat the steps 2 to 4 again until the convergence is achieved. Important part that we need to understand is once the clusters are formed and achieved, there is no scope for the centroid to move their position anymore. How to calculate the performance of the algorithm? One way to evaluate the performance is by measuring its accuracy. But for accuracy, we need to compare the test or test the obtained results with the ground truth or the known results. Since the K-mean is unsupervised algorithm, it is unlabeled and hence we do not have ground truth with us. One of the way is measuring average distance from the data points to the centroid and number of data points available in the cluster. Hence, we can find intra-cluster distance average as well as the inter-cluster distances for evaluation purpose. One more key problem is what should be the value of k. Determining how many clusters are required to form the K-means algorithm is often a task. Cluster information formation or value of a k depends on data space and formation of data point distribution. Routine approach is run the algorithm for different values of k, and for each k value finds the mean distance between data points and the centroid. This gives insight about density and cluster and average error for the cluster. But as we increase the value of k, number of clusters will increase. With each increase in number of clusters, the data points will be more close to the centroid and error will also decrease. So, the key question is how many clusters we should form. If you look at the graph where x-axis is representing value of k and y is the average error or distance from each data point to the cluster centroid. With increase in the value of k, that means clusters, the average error decreases, but after certain point of time, the decrease is very slow and almost steady. This is elbow effect. Till k equal to 5, we can see steady decrease in the error, but after k equal to 5, when we increase the value of k, there is no significant change in the average error. Hence, we can select k equal to 5 for this problem and form 5 clusters. At last, we conclude about K-means algorithm. It is very efficient unsupervised algorithm, particularly in case of medium and large size data sets. It is process of clustering around the centroid and selection of right k value to form the cluster is challenging problem as we can not specify in advance. Thank you very much for the lecture. In second lecture, we will continue with the coding in Python. Thank you. Have a good day. share, learn, and grow.